So in this video, we're going to see how to write methods that return a value. And we haven't forgotten about the error, but we'll get back to the error a little bit later. But again, we're going to start talking about methods, writing methods that return a value. So we've already used methods that return values. For example, if we have a look on line 64, we can see we're using an isDigit method. That method returns true if the character is a digit and false otherwise. On the line above, on line 62, we use the reader's read method. So what we're going to do is start by creating a still on track method. So we're going to use it to check that the car hasn't driven off the track. Because obviously we saw in the last video, we crashed when we actually hit the edge of the track. So at this point, I'm going to do something that may seem strange to you. I'm going to use the method before we've written it. We'll get an error, of course, but this can be a very valid technique when programming. The technique I'm talking about, it's called top-down programming, and it involves writing code at a high level, then filling in the detail later. The reason I'm using it here is so that we can see how we're going to use the method before we actually attempt to write the code for it. What we need to do is check that the car's still on the track after we move it. So the code might look something similar to this. So let's start making a bit of change to the code. So basically we're looking at the code after line 70. Going left, we'd want to test to see whether we crashed. So we could put if parentheses still on track, remembering the method name doesn't exist yet. So parentheses, then maybe we'd open a code block, and then we'd put our draw road method call in there. So I'll paste it into there. And then we might put on the end of that, have another code block, so an else, the left and right curly braces. Then we might do a print out to say, oops, you've crashed, game over. All right, so that could be our first version of the game. So you can see how, having done that, even though we haven't written the method yet, we've written the code to call it, you get an idea of how it's going to be used, and that can help you understand why we'd want it to return a value. So if the car is still on the track, we need to return true. If the cars hit the barrier at one side of the track, the method should instead return false. So now that we've done that, we can start to write the method. So what I'll do is I'll put the method still on track after main, before the draw road method. So we'll start typing it on line 109. So I'm going to type private static boolean and still on track. Then we've got our parentheses. Then a left to right code block, left to right curly braces, which creates our code block. I'll just put an extra line there. So we want the still on track method to return true or false, a boolean in other words, and we define that by specifying the type before the method name. In this case, the type is boolean for a boolean value, and you can probably notice by now that IntelliJ can be quite aggressive at flagging up potential errors. There's nothing wrong with this code so far, but the closing curly brace is underlined in red on line 111, and the error, if we hover over that, is telling us missing return statement. We've said that the method will return a boolean, and we're not yet returning anything. So that can be a bit off-putting when you're starting out, but there aren't many occasions when IntelliJ does this, and you'll soon get used to them though. So at this stage we can ignore that because of course we haven't written the code. Alright, so what is this code going to do? Well, we could check if the car position is decreased to less than 0, or if it's increased to more than the length of the road string, more than the number of characters in other words. So that would work at the moment, but we're planning on improving things later so that the road curves. The game's not very exciting after all with a straight road. When that happens, the road might curve right while the car's on the far left, and that would result in a car position still being greater than 0, but to the left of the road boundary. So if that doesn't make much sense, don't worry, it will when you see the road curving. So what I'm going to do instead though is check the character at the position where the car will be inserted. If that's a space, then we're within the two edge markers. If it's not a space, it means we've crashed into one side or the other. We'll talk about this some more once we've seen it working. So what that means is we need the position of the car so that we can see what's at that position in the string. And we also need the string itself that we're checking. So we've seen methods that take a single argument, but methods can and often do take more than one argument. So here we need the car's position and the string that defines the road. So let's create those, set up those parameters, typing int position, comma, string, road. Right, so let's write some code. We'll do a longhand version first. So it would be something like if parentheses, then another set of parentheses, position is less than road.length, the closing parentheses, then one more parentheses there, and the 2 ampersand characters, road.char@, then we've got parentheses, position, then outside of the right parentheses, equals, 2 equal signs there, we're checking for equality, and a space in single quotes. So if that's the case, then we can open a code block, return true, else return false. So that's our first stab at creating the method. We're checking to see whether the position of the car is less than the road length, so it hasn't gone off the road, and that there's a space in a specific position the car is going to move to. So that will work because we know that conditions equate or evaluate to either true or false. So if that condition that I've typed on line 110 is true or false, what we can do is just return the result of evaluating the condition. So we can simplify that. So I'm going to delete that code, making sure that I've left the closing right curly brace for the method. I'm going to change the if to a return. Then at the end of the line, I'm going to delete the left curly brace and put a semicolon on the end of the line to make that line valid. So I've done exactly the same thing now that we had previously, but now more concisely. And that's normally how you would find code like this written. Because we're not using if, the extra parentheses now around the condition are redundant. If you prefer to leave them in, that's fine. They're not doing any harm, but what I'm going to do is remove them. All right, so to delete that, I'm going to delete the extra ones that were sitting around here. So delete there, delete this one as well. Then that line is still valid. And again, I can do that, remove that extra set of parentheses because we've removed the if and we're now just returning the value of the condition. Okay, so we've now defined the method. What we need to do now is pass the arguments to this still on track method. So let's go back up to our code. And you can see we've still got an error there on line 71. We now need to pass the arguments that it needs to be able to process. So the 2 arguments were the position of the car and the road. So that'll be car speed, car position rather, comma, and then road, our const value for our road. Right, so now that we've done that, we've made the change, we can actually test this. So let's go up and build the jar file again. Build, menu, build artifacts, select build. We can open the project. We can right click in the output folder, the car game underscore jar, and select show in terminal, or open rather in terminal. Then we can type java space dash jar space car game dot jar. All right, so let's put a speed factor of 5 in. W, it's going 50 miles an hour. Let's go straight for a bit, and we'll go left now until the car crashes. And now we haven't got the program crashing, but we have got our error message that we put into the game to say that they've hit the side of the barrier and that it's game over. So that bit's now working well. What we haven't done though is terminate the while loop. So if I press D a few times now, the code's still running. So we've got the error or the message to say that the game was over, but in fact it's still running. So if I keep going back left now after the game over message, which I'll do now, and keep pressing left again, not only have we got the message a second time, but now the program's crashed as well. So we'll fix that and also detect a crash on the right-hand side in the next video.